Okay, good evening, Eric. I hope you can see and hear me. If not, just type in the comments. I think I'll do comments. Okay, there was a double noise. Sorry for that. I'm just trying to catch up with the configuration in my on my site. Okay, all good. Okay, so this presentation is the one I have similarly done before, and I had such good feedbacks about it, and I would like to also share with you today with some amendments that I have experienced lately. So I hope they are valuable for us, and please comment if in case you have also other experience on this topic. Why I choose application modernization with code refactoring, because I can see application modernization is like a buzzword lately. Like it's a bit noisy word, because I can see only containerization also sometimes referred as application modernization, or only moving to cloud sometimes referred as application modernization. In fact, I would like to emphasize that it is not just containerization, or it is not just moving to cloud. It also comes with code refactoring. This is the main topic of today, guys. And happy to get your comments regarding what you think, and if you would like to have any questions. Meanwhile, you can stop me. Thanks for DevOps Underground for this session before beginning. So I would like to begin with a story regarding the old Cuban cars. I hope you have seen such type of old Cuban cars. And you may be aware, due to sanctions, they are getting old, needs maintenance by time. So how do they really work today? I have researched about the story of this, and I will make a similarity with the topic of today. So old Cuban cars, they have been being polished, they have been maintained well enough to still be running and operating in Cuba, right? So how does it happen? uh, I found a similarity of just polishing the car, just making a nice looking one with but the engine is still old. Still, we are. It's like running in, like in like a high efficiency. So there's a similarity with moving an application to Kubernetes, containerizing it. Why? Because we have a legacy application. It may happen, right? I don't know if it's happened to you, but it's I'm experiencing such projects lately. So it may be a monolith, it may be a like 20 years old monolith, or it may be like 10 plus years old legacy. Still, it may be containerized. That's right. Still, you can containerize it. Still, you can upgrade the version of its programming language, containerize it, put in the Kubernetes. Don't make that any type of changes on the application layer. Still make it maybe three-tier application, let's say. So there's a similarity with this one, I think. Why? Because that time back, we don't really take care that much of the practices today, such as like cache policies, or such as the topics that I will mention shortly, but or such as the eventual consistency, or such as the new versions of high efficient programming languages, right? And software architecture. But what Cuban drivers have done is they changed their engine with the Japanese, mostly Toyota, Hilux engines, and they look like a brand new car, not just externally, also internally. Their engines are being also refreshed. Changed with the brand new Toyota engines. That's how they work today, and it's a real story. You can check, guys. So what we conclude here with a modernized vintage Cuban car with monolith, not at least modular monolith, let's say, not a legacy monolith, at least a modular monolith, or like an event-driven systems like SPAs or microservices. So we come up with a modernized Cuban car, just not polishing it, but also changing the engine. This is what I call application refactoring. This is the real refactoring, not just containerization. So I'm an ambassador, AWS ambassador. Can call me Dorian, ex-CTO on Amazon subsidiary and founder at Cloya. You can reach me out from the X handle you can see below. So just a quick intro who we are. We are an AWS Advanced Tier partner and several ongoing modernization projects since 2015. And what is the topic of today is majority of application modernization projects don't involve in code refactoring. I don't know your experience on this. Okay, John, thank you for the comment. The taxi I went in Kuba, Hyundai. Okay, that's a Hyundai engine, right? Yeah, not all of them are Toyota. Mostly I said Toyota. Up until my research, it was Toyota, but yeah, it was a Cuban car and with a Hyundai 2.7 engine, right? Yeah, perfect. You have also experienced this, yes. So they did not just modernize the application, they also really modernized the vintage Cuban car, right? Also changing the engine with Hyundai engine. And changing the engine is from my perspective, it's code refactoring, sometimes code re-architecting. This is the similarity of with the Cuban cars. So, what is the effect of this? So it's when you have the old Cuban car with inefficient engine, you just burn money, right? Even you move to cloud, you run your apps on Kubernetes, you run your apps on on-prem, not works efficiently. It needs resources more than the optimal, and based on of course it depends on your legacy application. It really depends on the architecture, but usually, up until my experience, it burns money if you just want to go out legacy application as is. And most of the time, up until my experience, legacy apps are also using a lot stored procedures on databases, which puts additional load on databases, which makes which raises up the database costs on your spendings. First, second, because they are relatively older technology, the utilization of cache, front end, and internal calls, and all of them are creating more CPU cycles, which is the reality, right? So what we are doing is we are replacing the old Cuban car, we are replacing the engine with a new Hyundai engine. So, but without refactoring, just forget about refactoring. What we have without code refactoring? Yes, without refactoring, modernization can be referred to as cloud-native transformations. Okay, with containers, Kubernetes, even we don't do any type of code refactoring, but still we have to at least write health check endpoints, right, for Kubernetes to make things right, or introduce at least some type of functions inside the code, such as secret management, or whether to make it 12-factor compliant with environment variables, like fetching the configuration from environment variables. So still we need some minor code refactoring. Still, we cannot escape from that, right? Plus, what may be modernization without refactoring? Graviton or Amran? Yeah, mostly it may be done without any code refactoring if your runtime also allows this. DevOps automation, increasing observability, or horizontal scaling, we call them, or at least I call those, modernization without code refactoring. So, one of my personal experience on this is one of the projects that we have run before is like an utilization on EC2 before Kubernetes is while the CPU utilization is like around 10%, it goes up to around 60% utilization, which means you do the same load with less number of servers, which means that optimization with Kubernetes is great. You can run the less amount of servers and run the same workload on it by increasing the utilization. How much increase the utilization? It's up to you. It's up to your policies, QoS definitions on Kubernetes. And Kubernetes is great to let you give you this flexibility, right? So you may extend it more, or you may keep it more yourself on the secure level, but you can, based on the pre-Kubernetes time, you can utilize your servers much more than as it was before. And next, Graviton, which is a ARM-based CPU, right? Whoever doesn't aware of Graviton, it's just an ARM. And which means that the instruction set is different than the Intel-based CPUs, which sometimes needs a bit effort on your side for the applications which needs compilation time, compile, like .NET. But it's worth that effort. Up until up until my experience on this, yes, based on your application version, you need to check it. The performance is relatively can be better or not better. You need to check your version of your application. And what are my 5 steps to modernize with code refactoring? So we have discussed without code refactoring. Any questions so far, please let me know. So just to make a recap of without refactoring, we are referring without refactoring is mostly like cloud native transformations, Gravity on run, DevOps automations, or maybe increasing observability or horizontal scaling, such type of modernization steps that code refactoring isn't involved. I call them at least, modernization, not app modernization. App modernization is not the one that you see on the screen now. So what I call app modernization are, and I will also mention slightly how AWS also contributes to that journey. So 5 steps of modernization. First of all, let's go through the benefits. Of course, as I mentioned, we burn less money, we increase the efficiency, gives us more flexibility, right, regarding the benefits. So think about a Cuban car. Engine is old, burns money, right? It costs more. On cloud also, if you move your app, legacy app, as is to the cloud, it will need most probably more resources than it should be if it was modernized. And first is, yes, you may know this, splitting the monolith. You may have a legacy application. It may sound super sexy or easy. In fact, not, right? Splitting the monolith. It has been around for almost more than a decade because we have experienced monoliths are less efficient for time to market, and there has been a movement around towards microservices. There are some companies who experienced microservices in good way, or there are some companies who experienced microservices not in the way that they desired. So it depends on the requirements, because sometimes I also see in the industry microservices is not all the time required necessary for all companies. It needs some certain requirements. So what is my number one suggestion for microservices? Moving to microservices. First of all, whatever you do, avoiding big bang. So industry has been suffering with big bangs a lot. What is big bang? For whoever didn't heard about it, in that sense is you develop your legacy from scratch, and you plan to replace your legacy in one day. So this is a big bang approach, which usually fails. Why it fails? Because you have to keep your legacy and the new version up and running together till the new version is developed. Usually takes a long time. So most of the time this is failed. Anyone has experience on this applying big bang? Let me know. Comment it, please. You may have a better experience than I did. My experience was not that good on that. Almost all the projects I was involved in, big bang was, let's say, succeeded, but it was like over budget, much more longer than expected. So usually it fails. Let me know if you have a good experience. So what is the alternative? Strangler fig. You may heard about it. You may tell me, I can hear that you are saying it is not that easy. Yes, it is not that easy. I know. What is strangler fig? For whoever haven't heard this before. So what is strangler fig? Is consider this tree is your monolith. This is your monolith on the left-hand side. I hope you can see my cursor. So think about, there's a branch. Here you see a strangler branch. And the strangler branch is getting more and more and covering the tree. It becomes a strangle tree. And after, all the tree inside is dead, and only we have the strangler fig left. This type of Strangler fig, I never seen in UK, but you may check it most probably in Amazons in Brazil maybe, but it's not something related with UK. But this explains us how to get rid of monoliths step by step. So the strangler becomes in a small branch first, which means that we split a certain function from monolith, and after another function, step by step, increasing the function that we have split it from monolith. And after some time, we will not need monolith anymore. So that's the story behind it. Anyone experienced with strangler fig, please let me know. I'm really interested. So how does it work on at the behind also? Just a couple of words more. Whenever you split a function from monolith, most probably you may have a relational database, and it's always a burden. It's always not easy to just split a function away from monolith, because still your database needs the data that this specific function needs. So during this migration, there may be that you may need some type of techniques to synchronize data, or maybe convert it to an event-driven and feed the data to both sides. Some techniques which may be a bit complex, but is it worth? Yes, if we can find the technique to keep the monolith up and running while moving some functions to strangler fig, it works. How AWS contributes to this? AWS has a migration hub. It's got a service called Migration Hub. So inside the service, you can just check how to split your monolith. So let me try to explain it briefly. You may check this yourself as well. So in the background, you see on the top, it's the modernized service here running on Fargate, and the one below is running on monolith. So on Migration Hub, you defined where is your monolith. You define the functions on the other modernized VPC. And Migration Hub helps you to step by step moving the functions from monolith to microservices. It gives you, of course, an infrastructure to make it easier not to deal with the network balance, load balancers, deal with the VPCs, security. It deals. It helps to move away from monolith, and also Lambda is also an option. Obviously, it does not help you on code refactoring. It's on you, but it does at least help you to experiment. One comment from John: I have done big bangs successfully, moving, building data centers, but given time and budget, it's best to plan around it, much less stressful. Yes, it's maybe a bit stressful. Big bangs, one day, stop everything, get up and running the next system. If something goes wrong, rollbacks is most probably not possible or painful, stressful for everyone. I know what you mean. I have also done similar. And the next is another tool of AWS. Most probably you are not aware. This is just a .NET example, but there are also other examples. This is for just .NET. So what does it simply does is select a similar classes inside your .NET code. So let's say in that particular example, there are bounded contexts around orders, shipping, inventory. This graph is built out from your .NET code. So this tool simply parses your .NET code and generates this graph on the screen. And you can select a particular bounded context here, and you can simply extract it from your monolith. So let's say you choose this, you choose orders, let's say, and you can see extract group, right? You choose the group, and when you click the extract group, it generates a code on Visual Studio, and it generates even the solution files. So it helps you to extract it away from the monolith. So this is just one example to .NET, but similar examples can be done on also other programming languages. Just to give an idea, it is possible up to an extent, because this type of tools obviously doesn't aware of the other bounded relations and bounded context and business. It gives you at least a flexibility to extract some of the services, but it's the decision is up to you whether this service should be extracted or not. Should it be modernized to an event-driven or not? So it will be in your hands to do it. Again, you can see that the extracted service, this inventory controller, and the controller code has been also extracted. So and the classes has been created. So all seems fine, seems work, but still needs to be validated and verified by you. Of course, this is a tool which helps you, which does not do the job end to end, but still a good progress. So this was the first one. Any questions so far? Let me know. This was an example for .NET, but never mind. That can be. There are other tools also in the industry. Reach me out if you are looking for some tools for modernization. I can suggest you based on your programming language. So second day Windowsification. We call it in our company like this. This word has been found by our team. Still not in Oxford Dictionary, but I'm not sure if it will be. But what does it mean? I think it's clear. Get rid of Windows. That's what I really like to do. Yeah. So the problem is Windows Server still not, if things didn't change the last couple of weeks, still doesn't work on ARM. You can check. I was surprised, but it's the reality. It doesn't work on ARM. Interesting, right? Only Windows 2000, like a laptop or workstation Windows 10, it works on ARM, but server now. It's interesting. Still, it's not possible, and we don't know if they have any plans to do it. So we don't know. So, and once we compare the performance between Intel and ARM. So again, this example is from .NET. I am referring to .NET here, but you can also refer Java, Go. You can also check based on your programming language. There are such benchmarks. But in this particular example, ARM has been performing better after a certain version of .NET, which was something .NET version 7x. Now, currently, .NET has version 9 even. So after a certain level, ARM is performing better. Of course, it depends on the benchmark. In each benchmark, they benchmark a particular function sets. So it depends on the benchmark. But still, it's a nice move forward. And in one of my project, I also tried it out. I can say with couple of Windows servers, my customer had peaks, like saturation on CPU, had to vertical scale. But after moving them away from .NET to .NET Core, yes, with Linux, with ARM, the CPU utilization with the same instance type went down around 30%, something like 30. So, which I also experienced. But this is between old .NET with the new .NET, not the one on the screen. This graph only compares same .NET, Intel versus ARM. I hope it is clear. So, next one. How AWS contributes. AWS is a toolkit on your Visual Studio, and it simply automatically runs assessment and porting suggestions on your .NET code. You can check it out with the QR code or from AWS website. It's a free tool. You need to just install on your Visual Studio. So, any questions so far? Please stop me. So we have finished 2 out of 5. We have 3 left. What we have 3 left? What I call real application modernization. So the next real application modernization is moving towards event-driven architectures. It has been around for a long time, but still the adaptation to it is in the industry still, I think, poor. I know Several new era companies that's been doing it, but still I think it's poor. Still, you need to progress on this. As one of the keynote of Werner, AWS CTO, two years back or last year, not sure, he mentioned about the world is asynchronous. So why our software is synchronous? Most of the software has been built in a synchronous way. All the CRUD operations, like classical CRUD operations, all the classical type of APIs, database calls, all synchronous way of building a software architecture. But the world is asynchronous, not synchronous. So how we will move away from a synchronous application architecture to an asynchronous application? It's challenging, of course, but once we get into bit by bit, step by step, we will see the advantages of it. But I don't suggest this to all businesses, guys. If you really need this, how you will know you need it or not? It's your business. You need to know if your business needs this first, if your team is need this, if your organization need this, and if the pros and cons of moving away from synchronous is beneficial for you or not. It's you to decide this. So the next is CQRS and event sourcing. I sometimes hear CQRS like moving away from just one database to the read-only database on AWS. You know, AWS, some of the services like Aurora provides you read-only databases. And they come and ask me they are doing CQRS by using the read-only database on AWS, but no, I'm always like referring CQRS with different comment and query models. So what does it mean, CQRS? Very basically, your comments and your queries, you segregate responsibility, comment query responsibility segregation. It's not like splitting or separating write database and read database. It should most of the time involve also the change in data model. If your data model changes in your comments, and if your data model is different on your queries, which it should be, because why you query a database, you make read operations, right? Why? Because it needs a specific particular reason of business, search, or I don't know, some particular order-based query if it's an e-commerce. So why you comment, there is no comment like update or inserts or changes on data for search, right? It is not. So they're different. So if data model is different, which means different databases or even different database technologies. One can be Elastic, the other can be Mongo, the other can be Dynamo, the other can be relational. So different databases. It means you are applying, it may mean, it doesn't mean, it may mean you may be applying CQRS in a better way. So event sourcing is on the top of event-driven systems. On the top of events, if your organization, if your business model lets you to apply event sourcing, go for it. It will bring you several advantages. Whoever is applying event sourcing, the system or the website or the service, whatever service it's giving, most of the time doesn't go down easily, because the system doesn't work like a classical way of CRUD operations, classical way of database operations. It works with events, and those type of systems, most of the time, may work a bit slightly eventually consistent, not transactional, mostly eventually getting there, getting the state that you desire, but most of the time are more robust. Any examples to eventual consistent systems around? Just comment it, please. There's a lot. I will give some examples at the end. But if you experience an eventual consistent service that you are currently using, let me know. Please comment. Okay. Next. I just mentioned eventual consistency. So the next is cache layers. Why I wanted to add also cache layers? Because I'm usually experiencing poor architecture or pure structuring of cache layers. There are several cache layers, right? There may be a cache layer on the CDN, like on the static side, right? Static content side. There may be cache layer on API gateway side. There may be cache layer on data cache, but still we may still enrich those type of cache layers. How? So those cache layers each have most possibly different cache policies, cache eviction policies also, right? Because each of those serve to different needs. CloudFront serves, or CDN, let's say, on the top, serves for static content. API gateway most probably serves for some certain type of data. Data cache also some certain type of data. But still, each of those layers should be carefully built to get away from unnecessary load on your backend, unnecessary cost on your AWS invoice, or unnecessary burden during peaks or operations. So, but if you define those cache layer policies not in the right way, it may affect your business, because those cache layers also brings some type of, let's say, some type of, let's say, I don't want to say risks, but some type of inconsistencies, data inconsistencies. So just careful about those. So that's almost all from my presentation today. I don't want to keep you more, because usually in my experience, half an hour is okay for the presentation. More is usually boring. And if you would like to ask any questions regarding any of your current projects or any of my projects that I experienced, just let me know. And thank you. Just reach me out on X if you would like. And if you would like to see any topics for the next time, also let me know. Comment, please. And thank you. Thank you for your attendance.